While we all are mostly familiar with systemic infections, ocular or eye infections often go unheard of, although it has devastating implications on quality of life. I, Dhanwini Rudraprasad, a CSIR SRF at LV Prasad Eye Institute, am working on one such sight-threatening intraocular infection called endophthalmitis, which majorly affects vitreous and retina. It progresses rapidly and is often a post-operative complication, especially after cataract surgery. It demands quicker and accurate diagnosis with prompt therapeutic intervention. However, the rise in culture negativity of the pathogens delays both. My PhD work focuses on developing an alternative approach using extracellular vesicles, which are nano-sized vesicles released by most cell types. EV carry molecular cargo, which varies based on the cellular microenvironment and play a role in cell signaling. We hypothesized that infection would alter EV cargo packaging, so we analyzed their proteins and miRNAs to understand what messages these cells are passing around through EVs during infection and identify potential diagnostic or therapeutic markers. So, our in vivo analysis of EV proteins and subsequent validation in the vitreous of patients with bacterial endophthalmitis, both culture positive and culture negative, identified complement 8 alpha and calpain 2 as key proteins, suggesting that these EV proteins may serve as reliable diagnostic markers. Similarly, in our miRNA study, MIR223-3P was observed to be upregulated in the vitreous and seemed to negatively regulate majority of the inflammation, especially NLRP3. Although inflammation is important to tackle pathogens, in endophthalmitis, however, it is a double-edged sword because the influx of inflammatory cells inside the retina disrupts the retinal architecture, causing irreversible vision loss. So, other than these proteins and miRNAs being diagnostic markers, the next part of our study would be to use miRNA-enriched EVs to regulate inflammation in bacterial endophthalmitis. Thank you.